So question 1 asks, how can the unit circle be used to construct the graph of f of t is equal to sin of t? This basically means f of x is equal to sin of x because this is the law of sines. Now the t represents the angles, and as we know, the sin of x represents the y values. So hypothetically, if we were to pick out some random angles, so which otherwise means at t is equal to 0, which means here sin of t would be 0, as we can see here. At t is equal to pi over 2, sin t or sin of x would be equal to 1. Same here with t at pi, the sin value would be 0, and at t is equal to 2 pi, it would be 0. So if we were to stretch out the circle and put it like this, it would look like the regular sine graph we know.
So question 2 asks us to compare the graph of y equals sine of x and y equals cosine of x. So they both are fundamentally the same wave in the sense that they both have the same amplitude, which is the height from the center line, and they also both have the same period, which is the length of one cycle, which is 2 pi. Now the only difference is their starting point, or their horizontal position. So the sine graph actually starts at the origin 0, 0, so right over here, and then the cosine graph starts at 0, -1, or 0, 1. So basically, this is simply a horizontal translation of the other graph. So to obtain the cosine graph from the sine graph, all you have to do is shift the sine graph pi over 2 units to the left. So when you look at the graph, the maximum point is at pi over 2. And then when you look at the cosine graph, its maximum point is at 0, right? So then you have to move the sine's maximum at pi over 2 to the cosine's maximum at x equals 0. So you move the entire graph pi over 2 units in a negative direction. So in terms of an equation, this ends up being the phase shift cosine of x equals sine of x plus pi over 2.
This is question 3, and it gives us a graph of average temperature over an idealized period of time. It asks for the highest temperature, which from the graph is around 70 degrees Fahrenheit. The lowest temperature is around the 20-degree Fahrenheit. And it asks for the amplitude, which is the maximum temperature minus the lowest temperature divided by 2. So that'd be 70 minus 2 divided by 2, which is 50 divided by 2, is 25 degrees Fahrenheit for the amplitude. And then it's asking the period for each iteration of the slope, which would be 3,500 years. And I actually didn't write down D, but it asks about whether the cycle goes upwards or downwards. And as you can see, it goes downwards. Question 4 is asking to write an equation of a sine function with an amplitude of 3 and a period of 4. The general form is y equals a sine b to the x, where a equals the amplitude, which is already given, so that's 3. And then the period is 2 pi divided by b, which is the period. So it'd be 2 pi divided by the period, which is given to us, is 4 pi. So b 2 pi over 4 pi is 1/2. So then plugging it into the general formula, it's y equals 3, which is the amplitude, sine 1/2 x, which is the period.
So question 5 asks, the voltage E in an electrical circuit is given by E is equal to 5.8 cos of 110 pi t, where t is time. So as we know, this is our formulas for this, and we will be using cos because it says cos. So the first question is, what is the amplitude? As we all know, the amplitude is the first integer there, so that is which represents volts. The period, as we know, 2 pi divided by b would be 2 pi divided by b, and then which gives us 1/55 seconds. Phase shift is C over P, which we don't have, so that is 0. There's no horizontal shift. So for part D, they ask us to graph this function over 2 periods. So one period is 1/55th of a second. So this graph shows the voltage, how the voltages go over time. So here we have our Y values, X values, and this is the maximum voltage values, and this is the minimum voltage values. As we know, in a cosine graph, we always start at the maximum. I did make a mistake. This is the first period, which reduces to 1/55. So this is 1/55. I did not reduce them here. So this is actually supposed to be crossing here. This is where the first period ends, and here is where the second period ends. So everything is correct except this is supposed to be passing through there. So we will see the correct version in the presentation, and that is number 5.
So question number 6 asks us to find the period of a function. Basically, in order to do so, the first thing you have to do is identify the first highest peak that you can see in the function. So the one that we see here is at t equals 4. So when the height is 4, that's the highest peak. And then when you follow through the graph and identify the second highest peak that follows the same pattern, you'll find yourself at t equals 16. So now you have to subtract the second highest peak by the first highest peak that follow the same pattern. So 16 minus 4 is 12. So the period of this graph is 12.